All right, let's get started. So this is the video about the cost, probability, and statistic for BB Tech students, semester 1 academic year 2024. As all of you know that the final exam is around the corner. So you're gonna have the exam next week. So in this video, we are going to go over the final exam syllabus, and also we're gonna take a look at the final exam from the previous academic year. Okay, let's go. So the date of the final exam. So as all of you know that the date of the final exam is next week. It's Tuesday, November 26th. Uh, and the time of the exam, it's going to be the morning time. Okay. From 8:30 to 11:30 a.m. Okay. The format of the exam, you're gonna have the multiple choice parts. So for the multiple choice part, you're gonna have actually 48 questions, not 50. You're gonna have 48 questions. Each question gonna be worth 1 point, and that means you're gonna have 48 points to collect here. And you're gonna also have show your work questions. This is the one that you have to show full work, including uh if it is a question about the hypothesis test, you have to show like 6 step full work. If the work that you have to show about the confidence interval, you have to show all steps. So this is going to be 3 questions, 22 points. Okay, 3 questions, 22 points. So in total, you're gonna have 70 points. And as you know that the final exam gonna be worth 35% of the cost grade. So that means we're gonna divide it 70 by 2, and that will be your uh, score for the final exam. Okay. All right. So the calculator, of course, it is allowed. Then it is, and also it is very important to bring a calculator to the exam because we are working with statistics, so you actually need to use a calculator on the paper test. You don't want to just calculate by hand. It's almost impossible to do it. All right. We're gonna take a look at the topics covered for the final exam. Basically, if you follow the handouts that we learn throughout the semester, you're gonna be fine. But this is a checklist one more time to make sure that you don't miss anything. So the topic cover is gonna start from first of all, gonna be the difference between the population versus sample. Well, for now, you should be able to tell the difference between the population and sample, right? Okay, next one, uh, basic properties of confidence interval. You should know what does it mean when I say lower bound of the confidence interval, upper bound of the confidence interval, or the margin of error or the standard error. What does it mean by saying that standard error of X bar, for example? You should know the components of the confidence intervals. And then also we're gonna cover on confidence interval for population mean when having a random sample drawn from a normal distribution with known sigma. Remember that if the population is normal and sigma is known, you're going to use the normal, standard normal test statistic C. And also you're going to have the case that you draw the sample from the population distribution and with the unknown sigma. So in this case, you use T. And then you also have the case that you're gonna use the standard normal as well. But this case, you draw the sample from any distribution, but you have big sample size. That one you can apply the central limit theorem and can use the normal. So as I told you, in class that the easiest way to memorize that you're gonna use T only one case when the sample size is small, which is n less than 30. And then, okay, I'm gonna write it down here. So you're gonna use T only when n is small, and then the population is normal, and also sigma is unknown. So if you have these 3 properties, So that means in that case, you're gonna have to pick statistic t, which is x bar minus mu over s over square root n, and then you can, build a confidence interval from there. Okay. So you should be able to calculate the confidence interval by hand and also by reading the output from R. Okay. So next one, we talk about the sample size necessary calculation for the mean. Of course, we learned this thing in class. And also we have confidence intervals for a population proportion. This is the one that the sample size is big enough. So we can use this normal distribution C to help us to build a confidence interval. And then we also learn the sample size necessary calculation for the proportion. All right. So don't worry about the formula here because the formula is all the formula are given in the formula sheet. So as long as you know how to apply it, you should be good. The formula, they are given in the formula sheet. Um, Next one, we take a look at the basic properties of the hypothesis test. So, you're going to learn the elements of the hypothesis test. I mean, you already learned uh, elements of hypothesis test, which is a null hypothesis, alternative hypothesis, test procedure, p-value, how to make conclusion, lot of things that you learn. You're gonna need to uh, know the definition of those terms. And then also we're gonna learn similar to confidence interval, but this time hypothesis test. You're gonna see the question that asks you about the hypothesis test when you work with the random sample that draw from a normal distribution with known sigma. Again, you use C. If you get a sample that's drawn, that is, pulled from the normal population and unknown sigma, you small sample, you use T. But when you have the huge sample size, that means central limit theorem can be applied as well. So that means you're going to use the normal distribution. All right. So similar to confidence interval, you should be able to calculate by hand. So you can calculate the thing called t-test and c-test, the one that we learned in class by hand. And then you also need to know how to compute the p-value. And then also you should be able to, be able to read the output from R. All right, next one, you're gonna see the question about the hypothesis test for population proportion using C. So this is similar to what you have here on a confidence interval, but a little bit different in, how to plug in the values. Um, and you're gonna have the question about hypothesis test for population proportion, but this time you use a program which is a binom.test function, binom.test command in R. Okay. Next one, you're gonna move to the two sample. Uh, from one sample, you're gonna move to the two sample test. So we're gonna take a look at a difference between two population means. In this case, you're gonna have three sub cases. So case number one, you have large sample. So you're gonna need to learn how to build a large sample confidence interval and also the hypothesis test. Well, of course, when you have big samples, you're gonna use the standard normal by the result of the central limit theorem. And then number two and number three, here, this is the case that you work with small sample. And you actually need to know the condition about the sigma, right? As I told in class that if you sigma 1 equal to sigma 2, which means you believe that you have equal population variance. So that means you're going to use the pool t-test. But if you have sigma 1 is not equal to sigma 2, you're going to use the Welch t-test. So you should be able to calculate it by hand and also by reading the output from R. The calculation can be tedious because the number that you plug in gonna be a little bit messy, but well, you should know how to plug in the concept because sometimes, and I think in the final exam we are not going to ask you to do the tedious calculation, but sometimes it's gonna be the concept question. All right. Next one, you're gonna see the question about analysis of pair data. So this one gonna be the part that we use the software only. All right, next one, it's the significance of the correlation coefficient. You should be able to do the t-test for the test about the parameter rho. So remember, we learned in class that rho, this is the correlation coefficient, and you can do the t-test for rho equal to 0 versus h1, for example, rho is not equal to 0, something like that. You can use the t-test to determine the result of this hypothesis test. Also, the regression part, so you should be able to read the output from our software and write down the regression equation on the baseline fit. The approach that we learned in class, we don't solve the intercept and slope by hand. So we're going to use the software to do it. But what you should learn is you should learn how to make the, you know, how to get the equation from the code, and also you should be able to make a prediction from the regression equation. You should be able to interpret the R square. You should be able to interpret regression coefficients. This is on both simple and multiple regression cases. All right, so the last two topics for the final exam gonna be the goodness of fit test by using the chi-square distribution, and also the test of independence by using the chi-square distribution. All right, to make sure that you have a sense what the exam looks like, so um, you're gonna see the sample of the final exam question from the last year exam. Okay. All right. So that is the final exam syllabus. If you have comments or if you have questions, you can leave it on the comment on the YouTube here. I will be sure to take a look after I post the video. All right. So let's go to the final exam packet handout here. So this is the final exam from last year. So you can download this final exam handout on the My Courseview website. So just log into the My Courseview website, and then you're gonna see the final exam packet in there. All right. So of course, in the final exam packet, in the final exam folder in our website, you're gonna see the final exam formula sheet as well. Be sure to take a look so you know what formula will be given on the exam. And also for this year exam, we're gonna have the value of the Q norm, which is the value that you're gonna use to find the critical value for the hypothesis test, and also sometimes it's gonna be useful for hypothesis test as well. I mean, sometimes Q norm value gonna be given on the cover page as well. So on the exam. On the final exam this year, you're gonna see that I give you Q norm 0.975 equal to 1.96. And also I give you Q norm 0.995. For example, I'm gonna give you to be 2.576. And also I have Q norm 0.95, which is 1.645. These number, they are given on the exam, so you don't need to memorize, but you're gonna use all the numbers here on the way when you do the exam as well. Okay, so this is the exam from last year. So last year we have the multiple choice questions, and then also we have the show your work question as well. So let's go question by question. It's gonna take a while to complete everything. So because I'm gonna just take a look question by question, and I'm gonna explain you how come of the answer. Maybe it's gonna take 2 hours for this clip. Okay, let's go. So for the multiple choice question, I think we have 45 questions last year. So question one, you conduct a poll in which you randomly selected 300 registered voters from Bangkok and asked if they approve of the job their governor is doing. Which of the following is the population in this study? So the population is actually the keyword is the population here. The population is actually um, the entire unit of the study here. So what is going to be the answer on this question? So let's take a look at the choice. Choice A is like the governor of the Bangkok. Choice B is 300 people that you interview. Choice C, those people who would answer yes in the interview. Part D, choice D, those people who would answer no in the interview. And choice E, all registered voters in Bangkok. So basically the parameter that you are interested in now, you're trying to, well, I mean, go back to the question. So you conduct a poll and then you select 300 people from Bangkok, which means that 300 people here that you interview, this is just a sample, right? So if you know that this is a sample, so the population gonna be all registered voter in Bangkok, right? Because the sample gonna be the subset of the population. So this is only just the sample of 300 people. But actually what you want to know is you want to know the population parameter, which is the proportion of, the proportion of uh, people in Bangkok who answer yes in the interview. For example, that is going to be the answer for this question gonna be part E, choice E, sorry. All registered voter in Bangkok. This is population of your study. Okay. All right. Question 2. All right. To determine the average body mass index BMI of students. Okay, to determine the average body mass index BMI of students in Chulalongkorn University, Nathan interviews and calculate his classmate BMI in the 3 classes he is currently enrolled. Then he take the mean of this BMI. From the above situation, what is the population parameter in his study? So actually what he did is he draw a sample, right? Because he draw a sample uh which is the people from his 3 classes that he is currently enrolled. So he draw a sample and then after that he computes the mean of the BMI of those people. So that mean this is the mean of the BMI from those people he sampled. This one gonna be statistic, right? And the population parameter gonna be the one that gonna be the mean BMI of Chulalongkorn students, right? It must be choice B because this is you know, whoops, they give you that the mean of BMI here gonna be just statistic, which you use to estimate population parameter. The parameter gonna be the mean BMI of Chulalongkorn students. This is the answer for this question. All right. Uh, Question 3. To construct a 95% confidence interval for mu by using the T distribution, you draw a sample of size 15 and you calculate X bar and S from the sample. Which quantity is guaranteed to be in the 95% confidence interval you form? So the choice you have 0.95, 0.05, S, mu, or X bar. Which one? So you can see here that if you build at 95% confidence interval, the thing that gonna be in the middle is going to be X bar, right? Because you build at 95% confidence interval for the mean, for the mean here. So the point estimate for the mean is X bar. X bar gonna be in the middle. And as we learn in class that you're gonna, extend both sides by some amount. The amount that you extend on both sides here, it's going to be T alpha over 2S over square root N. This is the one that you actually learn in class that, hey, you can do it by using the formula here. So the quantity that gonna be in there in the confidence interval for sure must be X bar because X bar gonna be in the center for sure. Mu is, you cannot guarantee because sometimes mu is the true value of the mean, right? So sometimes it's gonna be outside, sometimes it's gonna be inside. Well, but I mean, because you set up that 95% confidence interval here, so a lot of time, 95% of the times, the mu gonna be inside the interval, but only 5% of the time it's gonna be, sometimes the sample that you get is like pretty bad. So it is possible that the confidence interval does not cover mu. And S, this is nonsense. 0.05 and 0.95. This is no guarantee that all these number are gonna be in the confidence interval. All right. Next one. Oops. Oh, this is the formula sheet, everyone. This is the formula sheet that you have on the final exam. Okay, you can see that here you're gonna have the formula for the confidence interval. For you actually get three formulas for the confidence interval here. So this is the case that you work with the population mean and you want to use C. This is the case that you work with the population mean and you want to use T. It's one sample t-test here. And this is the case that you want to work with population proportion and you use normal because the sample size is big. So you have the formula here, and also you have the corresponding hypothesis test. Sorry, you have the corresponding confidence interval here. And also for the two sample, so this is the formula that you get. So which last sample you have here, the standard normal statistic. And then this is the pair t-test statistic, which, we're gonna ask you as a program, the R program here. And also with the small sample case, you have the pool t-test and the well t-test here. So, and this is SP in the pool t-test, and this is the degree of freedom in the well t-test. And this is a formula for the sample size necessary. You have two formula here. And then also you have the chi-square test and also the t-test to test the rho equal to 0 versus rho is not equal to 0 as well. All right, so this is the formula sheet. All right, let's keep going. Question 4, continue from question 3. We know that the formula of the 95% confidence interval is x bar plus minus t alpha over to s over square root n. What would be the most appropriate R command to get the t alpha over 2? So the t alpha over 2, as I told you in class, that when you have the t curve, the center gonna be at 0, right? And then you actually, if you want t alpha over 2, which is here, so that means you're gonna have the area on the tail on both sides to be alpha. So it means when you write a notation t alpha over 2 here, it means the area here gonna be just alpha over 2, right? So if you want 95% confidence interval, so that means you keep 95% in the middle, and that means the area on the tail gonna be 5%, and then you split two tails, so this one gonna be just 2.5%, so the area on the tail. So which means if you put yourself there, so it's gonna be QT 0.975, right? It's going to be 0.975 because the area from where you stand here, the area on the left to the point that you stand is 97.5 because it's 95 and 2.5 here, it's 0.975. And then comma, the degree of freedom, which is n minus 1. But on the previous question, you get the sample of size 15. So once you get the sample of size 15, so this one gonna be 14. All right, so the R command that you're gonna use for T alpha over 2 gonna be choice B. All right, QT 0.97514. Next one, continuing from question 4, what is the term T alpha over to S over square root n called? So of course you have X bar in the middle, and then you have this as a T alpha over to S over square root n. And then the confidence interval here on both sides, upper bound, lower bound over there. So this number, which is the one that I highlight in yellow now, this is going to call what in theory is gonna call the margin of error, right? So it's actually the margin of error because it's the uh, measurement from the center here to the upper bound or the lower bound of the confidence interval, which is called the margin of error. All right, next one. If you use the same data to build 90, 95, and 99% confidence intervals from mu, which one is the narrowest? So you know that the formula is x bar plus minus t alpha over 2 s over square root n. And even you use the x bar plus minus c alpha over 2 sigma over square root n as well, the pattern gonna be the same because the center gonna be x bar, right? And then and the value of s and square root n gonna be the same. I mean, s over square root n or sigma over square root n because you use the same data set. So it's gonna be the same, this value, this value. So that's mean the one that's gonna tell you that it's gonna be narrow or not. I mean, it's which one is narrower, which one is wider. It's gonna be the term T alpha over 2 here. That's gonna be the one. And as you know that or C alpha over 2, as you know that we have the pattern that you can see that if you work with 99% confidence interval, this number is 2.576. If you use 95% confidence interval, it's 1.96. If you work with 90%, the number is 1.645, which means you can see that when the level of confidence getting higher, you get bigger number of the critical value here, which means if you get more percent here, you're gonna have wider confidence interval, right? Because this number is bigger, and then well, when the number here it's bigger when the confidence level is higher, so that means you're gonna have wider confidence interval, which means the one that is the narrowest gonna be 90% confidence interval, right? All right, keep going. All right, next one, question 7. A manager is considering instituting an additional 15-minute coffee break. If it can be shown to decrease the number of errors that the employee commit, the manager divided a sample of 20 employees into two groups of 10. Member of one group follow the same work schedule as before, but the member of the other group were given a 15-minute break in the middle of the day. All right. So let mu1 be the mean number of error committed by the group with the coffee break. So the group with the coffee break gonna have the mean of the error committed as mu1. Mu2 gonna be the mean number of error committed by the group without coffee break. Okay. So what would be the most appropriate noun and alternative hypothesis in this context? So as you can see that I told you in class that equal to 0 must be on the null hypothesis. So that means choice A and B, both of them are wrong for sure. So you have C, D, and E here. So this must be equal to, and which one is the correct one? Let's take a look. So you actually want to test that, the mean number of error for the group with the coffee break is less or not. So that means you actually want to test that mu1 minus mu2 is what? Less than 0, right? So you actually oh no, greater than, or let's see. Hold on. See, it's a little bit hard in terms of you have to interpret mu1 and mu2. So one more time, let's delete it and let's go one more time. So um mu1, this is the group with the coffee break. Mu2, this is the group without the coffee break. Let's say that if the mu1, let's put the number, uh, the error commit with the coffee break, let's say that it is with the coffee break is number 3. with the coffee break, they can have three. The mean number of error can be three. So the without coffee break, the mean can be five, for example, here. So that mean you want to test that mu1 minus mu2 equal to 0 versus, I mean, this is the case that you want, right? The case that you want is the case that without the coffee break, you have lots of error. And then when you have the coffee break, it can reduce the error and the number here is smaller. So the case that you want, it's going to be mu1 minus mu2 less than 0. This is the case that you want, because if this happen, that's mean it's actually mean the coffee break is effective because it can reduce the uh, mean number of errors committed from the employee. Okay, so the answer here gonna be choice D, because this is the target of the question of interest. It's going to be the one that the coffee break can reduce the mean number of error committed or not. Okay. All right. So that is question 7. A little bit tough, this question, because you have to think about the, the English or, the problem context. All right. Question 8. Continuing from question 7, you get the t-test minus 2.126 with the degree of freedom 16. Which of the following is the correct R command for the p-value? All right, this one is easy. So you're gonna have the t-test here. So let's suppose that you have the t-test here. T-test is actually minus 2.126, and the degree of freedom is 16. So the p-value, well, by the definition, the p-value gonna be the area on the tail, right? That is extreme than the t-test here. So because you actually, in the previous question, you actually see that you do one-sided test. So this one, you're gonna calculate the area here. And this area, gonna call the p-value. All right. You don't have to multiply 2 to the p-value because you actually have less than in the uh, alternative hypothesis. So actually, if you want to find this area, the code gonna be pt minus 2.126 and then followed by the degree of freedom, which is 16 here because it is given here. And the answer here gonna be choice A. Okay. Next one. Consider a hypothesis test mu equal to 0.4 versus mu greater than 0.4. Which of the following x bar would make the p-value equal to 0.5? So when the p-value gonna be 0.5, think this way. So if you have the test for the mean mu, for the population mean, uh, and you decide to use the whatever C test or T test, so you're gonna have the center at 0, right? Because it's gonna be standard, normal, or T. And then the p-value gonna be, well, look at H1 here. H1 is mu greater than 0.4. So whatever t-test is on the right-hand side here. So let's suppose that the t-test is here. T-test is here. So that means the area on the tail gonna be the p-value, right? If the t-test is here, the p-value gonna be the area on the tail here. So you actually want the p-value to be 0.5. You actually want the area on the tail to be 0.5, right? Because the area under the curve here, from what you learned with Ajahn Watt in the first half of the course, you know that the probability density here, the area under the curve is 1. So if you want it to be 0.5, it means you cut half. So it means if the t-test is actually at 0, you gonna get the p-value equal to 0.5 here. Because it's actually t-test equal to 0, it's cut here at 0.5. So which means the p-value equal to 0.5 gonna happen when the t-test or c-test, whatever it is, equal to 0. And that means x bar minus mu equal to 0, right? Right, because no matter what you use c-test or t-test, the top part gonna be x bar minus mu. The bottom part is s over square root n or sigma over square root n. It doesn't matter, but I mean, if x bar minus mu, the numerator here equal to 0, that's mean c test or t test equal to 0, which mean if x bar equal to mu, that one gonna give you the p-value equal to 0. And the mu here that you put in the test is the mu naught one. It's the mu naught one. This is the value that you want to test. So it's actually if x equal to 0.4, right? Because the value that you want to test is 0.4 here. So if the value that you want to test is 0.4, I mean, the value that you want to take is 0.4. If the x bar equal to 0.4, that's gonna make the numerator in the t-test or c-test equal to 0. And that's gonna make c-test or t-test equal to 0. And that's mean the p-value is equal to 0.5. So the answer here gonna be choice C. Well, this is not the easy question. Question 9. This is the one that you have to think so many steps and you have to pretty you have to be super good at the definition of the p-value to understand this question. All right, question 10. We fail to reject the null hypothesis at 0. We fail to reject the null hypothesis at alpha equal to 0.05. If you use the same data, what is the correct conclusion at the significant level 0.1? So when you reject the null hypothesis at 0.05, what does it mean? It means that the p-value is less than 0.05. What is going to be the conclusion at 0.1? So you actually know that the p-value is less than 0.05 for sure because you reject the null hypothesis at 0.05. So now if you know that if you switch the alpha to be 0.1, but 0.05 less than 0.1, so the p-value gonna be less than 0.1 as well. So that means the conclusion gonna be choice A. So you're gonna reject the null hypothesis as well because you are sure that the p-value is smaller than 0.05, which means it is less than 0.1 as well. Okay. All right. Next one. Question 11 to 13. We have the situation here. So in a recent study of 35 ninth grade students, the sample mean and sample standard deviation of the number of hours per week that they play the video game was 16.6 and 2.8 respectively. So what are the correct notations? Well, this one's super easy. So you sample 35 students. So n equal to 35 and you get x bar equal to 16.6, not mu, it's x bar. And also 2.8 here, this is actually compute from the sample. This is why they call sample standard deviation. These two numbers, it's sample mean and sample standard deviation. So the answer is gonna be choice D dog here. All right, good, easy one. So number 12, find the 99% confidence interval for the mean time playing the video games. All right, this one you actually need to compute x bar plus minus. All right, so this one, because the sample size big, the sample size 35, so you're gonna use C. All right. Actually, you can use T as well in real life because you don't know sigma, and well, you actually need to know that the population is normal in order to use T. But this one, let's say that because n is equal to 35 and greater than 30. So that's mean you can use the central limit theorem, and that mean you're gonna use the C as well. That mean you're gonna use x bar plus minus C alpha over to S over square root n. You don't know sigma, but you can actually estimate it by S. So it's gonna be 16.6 plus minus C alpha over to In this case, because you actually use 99% confidence interval, so the C alpha over 2 gonna be Q norm 0.995. How come? Because I draw the normal curve here, I have 99% in the middle. So that means I'm gonna need to have 0.5 on each tail. And that's mean the one that I stand here, that's gonna be Q norm 0.995 here because we have 99.5% on the left of where we need the value here. And that number is on the cover page. It's 2.576. So you're gonna use 2.576 here. And then S is 2.8. And then N gonna be square root 35. All right. And this is gonna be the final answer for this question. So I'm gonna put it in the calculator here. 16.6 plus minus 2.576 times 2.8 over square root 35, which is actually the number I have here is 15.381 and also 17.819, which is choice C here. So on the exam, remember as I told you in class that sometimes because you round the number too early, you probably get the number that is a little bit different than in the you see in the multiple choice, but you should choose that one as well because sometimes if you miss the third decimal here, it's okay. I mean, you just need to select that choice as well because sometimes the number that you get, you round it from this too early. That's why the digits can be a little bit different. But on the final exam, I am sure that the number that you see on each choice, they are far apart enough for you to see the difference. So you should pick the one, at least, I mean, the first decimal, I mean, they must be, the same with the answer that you get from your calculator, right? All right, so next one, 13. The C statistic, what used in question 12, give the name of the theorem that support the use of the C statistic when the sample size is huge. All right, this one is super easy. It's the central limit theorem here. So C, choice C again. All right, next one. A scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From the previous study, we know that sigma equal to 4.33 feet. What is the sample size need? So remember, for the sample size, you have two formula. So let's go back to the formula. You have two formula. Formula number one and formula number two here. So formula number one, this is for the proportion. Formula number two here, this is for the mean. So in this case, you're going to take this formula, which is n equal to C alpha over 2 sigma over E square. All right. Here, what we're going to use is we're going to use n equal to C alpha over 2 sigma over E square. And then you just need to plug in everything. So C alpha over 2 here, because you use the 99% confident, that means the C alpha over 2, it's gonna be as the same as before, it's 2.576 because you actually have used the same number that you learned before, 99% confidence interval. So it's 2.576. And then the sigma is given as 4.33. And your E, this is the error that you get. So you actually want to be sure that it's accurate within 2 feet. So this means E is equal to 2. All right. And then square. So once you hit it in the calculator, you're gonna obtain the number you want. So I'm gonna put 2.576 and then multiply 4.33 and then over 2. And then I'm gonna square all the numbers, which I get 31.10. And the tricky part for the sample size is that you need to round it up, right? Because you cannot take a sample of size 31.1. It's impossible. You have to get the size 32. So that means the choice D is the final answer for this question. All right. Next one. Question 15 to question 20. All right. So this is the question, the situation that you're going to use in question 15 to 26 question. So let's go. We have Watch Corporation of Switzerland it claims that it watches on average will neither gain nor lose the time during a week. A sample of 18 watches provided the following gains or losses in second per week. So you have all the number here, which is the 18 numbers here. So you have some of them are plus, some of them are minus. This is a time gain or time lose in seconds after 1 week. Okay, let mu be the true mean of gain or lose time during a week. Assume that the data in this context follow the normal distribution. We want to find a 95% confidence interval for mu and also test for the hypothesis mu equal to 0 versus mu is not equal to 0. Let's go. So question 15. What statistic is the most appropriate to use in this context? Well, because the population is normal, because you draw the data from the normal distribution and you don't know sigma, right? Sigma is unknown. So you actually need to use T. And also the sample size is small as well. You cannot apply the central limit theorem. So that means you're going to use a T statistic for this case because sigma is unknown and N is small. And actually the population is normal as well. So that means the choice that you're going to use here going to be choice B. All right. Next one. To calculate the 95% confidence interval for mu, what critical value do we need? All right, so you're gonna use x bar plus minus t alpha over 2 s over square root n. And this number t alpha over 2, this is the one that called the critical value. So you're gonna use qt 0.975 followed by the degree of freedom, which is 17, right? Well, if you don't know, you're gonna build a 95% confident interval. So that means you keep 95% in the middle and 5% on the tails. And two tails, you're gonna have 2.5% here, 2.5% here, which you stand here, it's gonna be QT 0.975 because you have 97.5% on the left of you, and the degree of freedom, it's gonna be n minus 1 as you have in the formula. So the degree of freedom is n minus 1. So that means you're going to use 17 here and you pick choice A. You can see that the question 16 actually give you the value as well because you may need to carry this number to calculate in the next question. All right, so for your convenience, we use R to help in calculation and obtain the mean and SD. All right, this is the output from R. So you get all 80 numbers from here and you actually plug it in R. So you're gonna have mean and SD here. All right, next one. I want you to calculate a 95% confidence interval for mu. Note that the value of T of R2 or C of R2 was given in the multiple choice question 16. Okay, so what you're gonna do is you're gonna use X bar plus minus T alpha over to S over square root N. And X bar in this case, it's gonna be minus 0.18389. That is X bar, right? X bar is here. And then you also have S, which is over there. And then the T of our 2 is going to be 2.110 from question 16. And then you have 0.30734. And then you also have square root n. And here going to be 18. Remember that we have 18 watches. So I'm going to take time to put it in the calculator. 0.18389. And then plus minus times 2.110 and then times 0.30734 over square root 18. All right, this is why I said that you need a calculator. If not, if you don't bring the calculator to the exam, it's impossible to compute this number by hand. So the answer is going to be minus 0.3367 and then minus 0.0311. All right, all 10. Yeah, choice D. All right, choice D is the answer for this question. All right, let's make sure that I hit the calculator correctly one more time. All right, good. All right, next one, question 18. So we already did the confidence interval part. The next one is the hypothesis test part. All right, so to test mu equal to 0 versus mu is not equal to 0, what is the value of the test statistic? All right, so you can use the t-test here, which is going to be x bar minus mu naught over s over square root n. X bar here gonna be 0.18389, and mu naught here is 0 because the value that you want to test is actually 0 here. You see? And then S is actually 0.30734, and N here gonna be 18 here. So you're gonna do the calculation here one more time. So I'm gonna do the numerator, that one, 0 minus 0.18389, and then over 0.30734 over square root, and then 18 here, which the number that you get here, it's going to be minus 2.538, which is the choice B. It's the correct one. So this is the t-test of the hypothesis test. All right, next one, question 19. So continuing from question 18, what is going to be the correct p-value? So here, the p-value, you stand here, not you stand here. So this is the t-test that you get is minus 0.358. So you actually need the area under the curve on the left here. But this time you actually do H1 to be two-sided test because you do the not equal to side. So when you do the p-value, for this question, it's gonna be 2 times probability of uh, the statistic t less than minus 2.538. So basically, you actually get the area on one tail, and then you multiply 2 to get another tail. This is because you actually do the two-sided test, okay? So you have that one. That means you actually need 2 times pt minus 0.358, and then the degree of freedom is 17 for this question because you have 18 as a sample size. So this is actually the number you're looking for. So it's actually 2 times 0.0106, and that means it's gonna be 0.021. Hold on. It's gonna be let's see, it's gonna be 2 one more time, 2 times 0.0106. Hit the calculator, it's gonna be 0.0212. And wow, that is choice E. So none of the above is correct. So this is actually the tricky question because there's no answer on choice A, B, C, D, because choice A, B, C, D is they are all wrong. All right, so next one, question 20, state the conclusion in this context, alpha equal to 0.05. All right, so because the p-value that you get from the previous question here, this is less than alpha that you set to be 0.05. So that means you reject the null hypothesis. That means you believe that the true mean gain or lose time during a week differs from 0, right? Because you do two-sided tests. All right, this is choice A. All right, next one, question 21 to 23. Chulalongkorn University consider replacing face-to-face classes with online ones. Before the final decision is made, the admin contract a sample of 350 students. After present with this option, 250 indicated they would go for online learning and suggest it replace the face-to-face classes. So question 21, estimate the value of the population proportion in this context. So of course, the population proportion in this context is gonna be X over N. X here is you have 250 students who say that they would go online. So it's 250. But the 350, this is the total number on the sample. So if you do 250 over 350, that's going to give you the p hat, which is 0.714. So it's going to be choice D. And then the next one, question 22, which of the following is the 90% confidence interval? All right, so for the population proportion P. So remember the population proportion P is the P hat plus minus C alpha over 2 square root P hat 1 minus P hat over N. One more time, if you cannot remember this one, you can just go back to the formula sheet, and then you're gonna see that the formula sheet there you have the formula. So you can just copy from the formula sheet over there. Okay, so you're gonna have p hat plus minus c alpha over 2 square root p times 1 minus p over n, and then you plug in everything. So it's 0.714 plus c alpha over 2 here. It's actually 90% confidence interval. So you save 90% in the middle, and then you have 5% on each tail, right? Because you actually need 100% under the curve. So the value that you stand here, this is actually Q norm, 0.95. And if you take a look at the cover page, it's gonna be 1.645. So it's 1.645, and then square root 0.714 times 1 minus 0.714, and then over n, which is 350. This is a question that because we don't use the p hat as the exact value, because if you plug in 5 over 7, I mean 250 over 350, this is actually 5 over 7. And then I only cut only 3 digits here, you see? And then I use the 3-digit number here. So I mean, sometimes if you round the number too early, if you do say 0.72, for example, 71, for example, you only keep 2 digits, for example. The number that you get here can be like a little bit off from the last digit in the multiple choice, but trying to pick the one that, close to the one that you get from the calculator, because uh it depends on how you round the number too early or something or not. So we're gonna hit the calculator now. Give me a minute. Shoop. I'm gonna hit the calculator. Shoop, shoop, shoop. 1.645, and then times square root 0.714 1 minus 0.714, and then over 350. So after I hit the calculator carefully, so the number that I get is 0.67 to 0.75. So the choice gonna be choice B. So it's 0.675 to 0.754. Okay. All right. The number can be off a little bit, because sometimes people round this number too early. All right. Next one. Question 23. Uh, what statistic do we use to build a 90% confidence interval? In question 22, of course, it's gonna be the normal distribution, standard normal distribution. All right. Choice A. All right. Next one, question 24 and 25. A new survey is to be undertaken to estimate the proportion of durian lovers in Thailand. Suppose that you were designing a survey and wish to estimate the proportion correct within 0.02 with the probability of 0.95. Question 24. How many people should be included in the sample if you know from the history that p hat equal to 0.65? Of course, you need to go back to see the formula. And the formula is here, which is C alpha over 2 times square root P times 1 minus P over E, and then everything square here. So we're gonna take this one and we're gonna plug in. So it's gonna be C alpha over 2 square root p hat times 1 minus p hat over e, and then everything squared. Then you get an n, and be sure to round up the number after you get the calculation, after you complete the calculation. So that's C alpha over 2 here because you actually want the confidence to be 0.95. So that means the C alpha over 2 gonna be 1.96. It's a Q norm 0.975. 1.96, and then that p hat gonna be 0.65, and then 1 minute p hat gonna be 0.35, and then over e, which is e gonna be the error, which is correct within 0.02, and then you square it. All right, we're gonna do it here. So it's 1.96 times square root 0.65 times 0.35, and then over 0.02. All right, so you're gonna get the number over there, and then you square it. So the number is 2.84.91. If you round it up, it's gonna be choice C, which is 2,185. All right, next one. So how many people should be included if you have no idea about the true value of P? So as we learned in class that the formula here, you can actually use it as well if you don't know the value of the P hat from the history. So if you don't know from the history, the P hat that you're going to use is 0.5 because this is the worst case, right? Because we learned that from calculus, the function x times 1 minus x, we're going to have the critical value. We're going to have the max or min, which, at the critical value, x equal to 1/2. So in calculus, you can do it here. So that means if you plug in 0.5, it's going to be the worst case. So if you change this thing to 0.5, that's going to be the answer of question 25. So we're going to copy this one, and then we're going to paste it here. So this is the answer for question 25, which is actually, you need to change this thing a little bit. Everyone change it to 0.5, 0.5. All right. And that will be the answer for your question 25, which I'm gonna compute it now. It's 2401, which is question E. Choice E, 2401. All right. Next one, question 26 to 29. The hourly wages in the particular industry are normally distributed with the mean 13.2 and standard deviation 2.5. A company in this industry employ 40 workers, paying them an average of 12.2 per hour. Can this company be accused of paying substandard wages? Use alpha equal to 0.01. All right, so what is the null and alternative hypothesis for this problem? So you actually have the question that they pay substandard wages or not. So you actually want to test that the 13.2, the one that they claim in the particular study here, this is true, or it should be 13.2 or something less than 13.2 or not. Does it make sense? So because you actually want to know that they pay substandard wages or not. So the correct answer and the most appropriate one, it's gonna be choice C, because you put the equal sign here, 13.2 and less than 13.2 in the alternative hypothesis. All right, that 12.2, this is not in the now our alternative hypothesis. That one is the value of the X bar. I mean, after you draw the sample. All right, so what is the value of the C test? All right, so we're gonna do C test. This is actually X bar minus mu over S over square root N, right? So it's gonna be X bar 12.2, and then minus, because the sample size is big, so you can apply the central limit theorem and use C. All right, mu, the value that you want to test is 13.2, because this one, the value that you want to test, 13.2, And then also you're gonna have S, which is uh oh no, not S, it's sigma, right? Because you have standard deviation normally distributed here with the standard deviation 2.5. All right, so it's actually sigma because you actually know that sigma is 2.5 over square root n. N here gonna be 40. All right. And all right, so you're gonna get the answer pretty soon. So it's minus 12.2 minus 13.2, which is the minus 1 over 2.5 and then over square root 40. All right, make sure when you hit the calculator, this is actually sigma over square root n. So it's similar to you divided by sigma and then you multiply square root n at the end. I mean, the same thing. So next one, once you hit the calculator, you're gonna get minus 2.53, which is question A, choice A, sorry. Question 28, what is the p-value of the test? Of course, the c-test here, you have the c-test of minus 2.53. So here, it's going to be your p-value, which is going to be the area on the left. And then you do one-sided test, you see that? So that's why you don't have to multiply two. So the p-norm here, see the p-norm, the value of the p-norm here, gonna be the answer of this question. So choice A as well. So this is the p-value of the test. All right. With this p-value, you reject the null hypothesis. So that means you reject the null hypothesis. And that means you believe H1. So you believe that mu less than 13.2, which is there is enough or sufficient evidence to suggest that this company can be excused for paying substandard wages on average. So choice B is the correct answer one. All right, next one. All right, question 30. All right, we have here that the crime survey state that 23% of gun owners are women. A researcher believed that in the area where he lived, the percentage is more than 23 because maybe he think that he sees so many gun owners, women gun owners. So he randomly select a sample of 80 gun owners and finds that 22 are women. So he conduct the hypothesis test to check if the percentage of female gun owners in his area is more than 23%. What is going to be the correct alternative hypothesis in this context? So of course, because he want to know if the percentage is more than 23 or not. So choice A and B are wrong for sure. So it should be choice D. All right, because P greater than 0.23 or not. All right, next one, question 31. What is the value of the c-test? All right, you're going to use c-test as well. But this time, remember that the formula is on the formula sheet. We're going to go back a little bit. You have here, so p hat minus p naught over square root p naught 1 minus p naught over n. All right. So you're gonna have the c equal to p hat minus p naught over square root p naught 1 minus p naught over n. Make sure that you plug in the correct one because p0 here is actually 0.23. Okay, so p hat here is, okay, you need to find p hat first. So p hat is 22 out of 80, right? So out of 80 people, you have 22 women that own gun. So that means the p hat, it's gonna be 0.275 because it's 22 over 80. And then what you have here is 0.275 minus 0.23 over square root 0.23 times 1 minus 0.23, which is 0.77, right? And then over n here is actually 80. All right. Once you hit the calculator here, you should get the answer. 0.275 minus 0.23 over square root 0.23 times 0.77 and then over 80. All right. The answer here is 0.956, right? 0.956. That's the one that you have. So it's choice E. All right, next one. If you denote the correct c-test in the previous question as an X, what is the R command for the p-value? So the p-value gonna be, all right, you have c-test is 0.956. So that's mean, and you do the hypothesis test p greater than 0.23 as the H1. So that means the area that you want, it's area on the tail here on the right hand side. So which mean if you want to find the area on the right hand side, well, you know, the center is at 0. That means you're gonna need to use 1 minus p norm first, right? And then because if this is X, so area on the left gonna be p norm X. So area that I highlight in green here gonna be 1 minus p norm X, which is choice C. All right. Next one. You don't need to multiply two because it's actually one-sided test. All right. Question 33, the p-value from the program is 0.1695. What is the correct conclusion? Well, of course, the p-value is big. That means you fail to reject the null hypothesis. That means you should believe H0, which means you're gonna believe that, well, this means you fail to reject H0. That means you believe that P equal to 0.23. Or that means you don't have enough evidence to conclude that P greater than 0.23. So the correct answer is there is not enough evidence to believe that the percentage of female gun owner in his area is higher than 23%. Is choice C. Okay. All right. That is the correct one. Next one, question 34. Annie wants to check also if the percentage of female gun owner in her area is more than 23%. She takes sample from her area. However, this time the sample size is small, so that's why she cannot use the normal test like the previous question. She only get n equal to 16, therefore the C statistic cannot be used. Binomial test will be used in this case. Out of 16 women, there are 4 women who own gun. What is the correct command to find the p-value, for finding the p-value? All right, so of course, this time Annie, she used n equal to 16. So when you do the binomial test, so the binomial test is gonna be the one that work with the population parameter p, but this is the time when the sample size is small. And I mean, it work with any sample size, but when the sample size is small, you have to use binomial test because the C test that you use here, it work only when the sample size is big. Okay, so when the sample size, is small, we prefer use the binomial test, and then you can have n equal to 16 here, and then you can see that there are 4 women out of 16 who own guns, so x equal to 4. So it looks good, A, B, C, D. Now, the P here gonna be the value of that you wanna test, which actually 0.23, right? Because you wanna test that the in her area it's more than 23 or not, that the percentage of female who own gun. So it's actually 0.23 here. And the alternative hypothesis, you just get it in. So it's gonna be choice B here. All right, so the choice B is the correct one. All right, this one gonna give you the p-value for the test that corresponding to any. All right, next one. All right, we come to question 35 now. CAMP or cyclic adenosine monophosphate is a substance that can mediate cellular response to hormones. In a study of maturation of egg cell in frogs, oocytes from each 4 female were divided into 2 batches. One batch was exposed to progesterone and the other was not. So actually you get the oocyte or the cell from the frog, something like that. And then you split into 2 groups. So the first one, I mean, you have 4 sample, frog 1, frog 2, frog 3, and frog 4. And actually you split into, like for sample number 1, frog 1 here, you split the same frog into the sample from the same frog into two groups. Group number one, not treat with progesterone. Group number two, treat with progesterone, and you take a look at the CAMP level. All right, which you have the data set here. Assume that the difference are approximately normal. Okay. All right, so the R code is given here. You can see that it look like it's gonna be the pair t-test, the one that you're gonna use, the pair t-test here. You use the pair t-test because actually, you can see that for each data set, I mean each uh pair here, you can see that the samples that you draw are not independent because the number that you see here, they came from the same frog. This one, they came from the same frog. So they are not independent because we use the same subject and then you split into two pieces. This is similar to, when you do the before after analysis, right? Or something that you compare and then you get the sample from the same subject. All right. Okay, we're gonna use the R code here without and with. So you input four numbers here. You use a t-test here. So the correct one that you are looking for is going to be this one. T-test without with pair equal to true, alternative equal to greater. Remember that if you use the pair t-test, you have to type pair equal to 2 here. This one is not correct because you use variance equal to 2. This is the pool t-test, which is not applied to this question. All right, but I mean, this is the extra information that you shouldn't look at it. All right, next one, question 35. We let MUD to be the population mean decrease in CAMP due to progesterone. What is the correct t-test for MUD equal to 0 versus MUD greater than 0? Well, basically what they ask is like the code that I highlight in green here. So the t-test gonna be 3.3387, which is here. All right, so the answer is choice D. All right, next one. State the conclusion. Mu d equal to 0 versus mu d greater than 0. All right, because the p-value that you get is this one that I highlight in yellow. It's 0.022. I mean, if you use alpha equal to 0.05, you reject the null hypothesis. So the decision is we reject the null hypothesis. So you're gonna pick mu d greater than 0, which means you're gonna pick that there is sufficient evidence uh, there is sufficient evidence that exposure to progesterone under the experimental condition causes a decrease in mean CMP level. All right. So it means you believe that mu d greater than 0. That's it. All right. Question 37. Which of the following is the R command you would use to find 98% confident for the mu d? All right. Which one that you're gonna get the mu d, the confidence interval 98%? So of course, first of all, you can take a look that you actually need a pair t-test. So the choice that uh, still makes sense is choice A, choice B, and choice D. This one is wrong for sure. This one is wrong for sure. And also, you actually need the confidence level of 98% because you want to do 98% confidence level. So this choice is not correct as well. So you only have A and B now. And also, you can see that when you hit for the confidence interval, you need to use choice B. You don't have to put, I mean, you shouldn't put the alternative equal to greater because this one gonna mess up with your confidence interval. You can try at home. I mean, if you type confident, if you type alternative equal to greater, it's gonna give you the confidence interval that we're not looking for. So what we're looking for is just like choice B, because choice A gonna give you another form of confidence interval which we do not cover in this class. Okay. So remember, if you want to do confidence interval, you do the two-sided test here. All right, next one. Question 38 to 41. All right, this page. School administrator wonder whether class size X and grade achievement Y in percent were related. A random sample of size 8 are drawn. So you get X and Y here. X is class size, Y is grade achievement. So correlation is minus 0.633. You want to check that is there sufficient evidence at alpha equal to 0.05 to claim that X and Y are correlated. So question 38, they're gonna ask you for the appropriate null and alternative hypothesis. So of course, from the theory that we learned, so the null and the alternative hypothesis should be choice B, right? Because not R for sure, because R is not the parameter, not the population parameter. It's just a statistic to estimate rho. So you have to answer in terms of rho. And choice B is the correct one because you actually want to test that they are correlated or not. So it's gonna be choice B. Well, not equal to sign mean correlated. But if you have less than sign, this means negative correlated. If the question asks you negative correlated, then you have to specify like that. So you need to be more specific and pick choice A. If I have the negative uh here, but here it's in general, so you pick choice B. All right, what is the t-test for this context? So of course t-test. So you can take a look at the formula in the formula sheet as well. So the formula for the t-test gonna be here on the last one, which is r times square root n minus 2 over 1 minus r squared. All right, let's go back over there. So we have r times square root n minus 2 times 1 minus r squared. So r here gonna be the correlation core xy. This is the one that you use in programming to find that small r parameter, small r statistic. So you're gonna have minus 0.633 and then square root n, which is what is the number size here? 8, and then minus 2, and then over 1 minus r, and then square. All right. So once you hit the calculator, so 0.6 minus 0.633 and then times square root 8 minus 2 over 1 minus 0.633 square. So all right, one more time. Square root 6 over 1 minus 1 minus 0.63 square. So the answer that you get is minus 2.003. So the choice B is the correct one. All right. From question 39, continuing from question 39, which range of the p-value uh, of this problem lie in? All right. So of course, if you have t-test equal to minus 2033, the degree of freedom that you're going to use here, it's going to be 6, right? Well, remember that the degree of freedom for this test is n minus 2 here. So degree of freedom is 6. That means you're gonna use the the top row here, PET minus 0 to minus 0.0. The t-test from the question 39 is this one, and this is the correct degree of freedom. So actually this one that you're gonna use. However, this one gonna give you the area on the left, right? But you're gonna need to multiply 2, right? Because the p-value here is gonna be 2 times the probability that t less than minus 2.003. Why is that? Because actually you need to multiply 2 because the sign is not equal to on the alternative hypothesis. So that means you're gonna multiply 2 with this number, and the correct p-value gonna be 2 times 0.046, which is actually 0.092. All right. And that means the p-value is higher than 0.05. That is the answer for question 40. So the p-value is higher than 0.05 because you actually multiply to the p-value as well, to the area on the left as well. All right. Question 41. What is the conclusion if you use alpha equal to 0.05? Well, now you reject the null. You fail to reject, sorry. You fail to reject the null hypothesis because this one is bigger than 0.05. That means you fail to reject. That means you believe H0. That means you believe that low equal to 0. You believe that there is no relationship, or in other words, it means X and Y are not correlated, something like that. So see which one. So, well, A and B, they talk about negative correlated. That is not correct. C and D, so let's see. There is, well, we should choose choice D then. There is not enough evidence to conclude the linear relationship between class size and grade, right? Because you believe H0. So you fail to reject H0. That means you believe that there is not enough evidence to conclude the relationship between class size and grade. Okay. All right. Next one. 42 45. All right. This is the last page for multiple choice. All right. Um, Barnsley investigated the relationship between month of birth and achievement in sport. Birth dates were collected for players in teams completing 1990 World Cup soccer games. So actually, he sampled so many people, and he want to know that the player in 1990 World Cup soccer games, um, the birth month is, we wish to test that whether these data are consistent with the hypothesis that birthdays of soccer players are uniformly distributed across 4 quarters of the year. So they actually want to know that if you split to each quarter, like August to October, November to January, February to April, May to July, something like that, the ratio between them gonna be 1 by 1 by 1 by 1 or not. So chi-square test is used. So what is the chi-square test here? Or of course, so you're gonna have observe. This is the OI. So you're gonna have the EI. So let's add all the numbers here. If you add 150 and also 138 and 140 and 100, so you're gonna have in total 528 people in the analysis, right? You have this is the total number of people who answered the survey here. But if you believe that the null hypothesis is gonna be 1 by 1 by 1 by 1, so it means that you're gonna you're gonna believe that the ratio is 1 by 1 by 1 by 1. So if you split 528 uh with the proportion 1 by 1 by 1 by 1, so that you're gonna get the EI. So if you do 528 over 4, so you're gonna get 132. So if the null hypothesis is true, it should be 132 all the way, right? It should be this one all the way. So this is the EI. So that means when you have the chi-square test, this thing gonna be O minus E square over E, and then you sum of it. So it's gonna be 150 minus 132, and then square, and then over 132, and then plus 138 minus 132, and then square over 132, and then plus 140 minus 132, and then square over 132, and the last 100 minus 132 square, and then over 132. All right, I'm gonna put it in the calculator pretty quick. So 150 minus 132, and then square, and then plus 138, which minus 1, which is 6 square, and then add 8 square, which is 64, and then minus 32 square. All right, so I'm gonna have the answer is 10.9697, which is actually choice C, 10.97. This is the value of the chi-square test. Question 43, the corresponding degree of freedom is what? It's actually the number of groups minus 1, which is 3, right? So you actually have this information on the formula sheet as well. For those of you who don't know, here, So this is a formula, and then you have the degree of freedom to be R minus 1, which is the number of groups minus 1 for the uh goodness of fit test. Okay. All right, keep going. We're almost there, everyone. All right, so the p-value from the program is 0.0119. What is the correct conclusion at alpha equal to 0.01? So the p-value is small, so you reject the null hypothesis at 0. Oh, no, 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 no. The alternative, the alpha is 0.01, but this one is 0.119. So that means you fail again. You fail to reject the null hypothesis. So you fail to reject the null hypothesis. That means you believe null hypothesis. So you believe that the true proportion or the true ratio is 1 by 1 by 1 by 1. So that means you believe that the birthdays are uniformly distributed across the 4 quarters. Right? So that's mean the choice D. That is the correct one. The chi-square test does not mean the linear relationship at all. So it's talk about the proportion on each category. All right, the last question on the multiple choice. 45, the following sample information shows the number of defective items produced on the day shift and the night shift for the sample of 6 day last month. Okay, you have here the data set. Which of the following statistical procedure would be most appropriate to test the claim that there are more detect item produced on the day shift? Assume that any necessary normality requirement holds. So basically, they ask you which of the tests is the best one to conduct on this one. So here you can see that you have uh, 6, the sample size 6, and from day 1 you have day shift, afternoon shift. Day 2 you have day shift, afternoon shift, but you have day shift, afternoon shift on day 2 as well, but you measure on the same day. So actually that's mean the first group and the second group, when you get the sample, they are not independent. So that means the two sample independent t-tests, you cannot pick B, C, and D. Because this one gonna be the case that you draw the sample independently. The one that you're gonna use is going to be the pair t-test, which is choice E. The test of independent is not correct as well, so choice E. All right. So that is the end of the multiple choice. You can see that, well, I spend like maybe like a lot of minutes. I think we we spend almost 2 hours on the multiple choice to explain it. But when you do it, when you do it on the exam, you don't have to explain, you know, to yourself, because you're gonna keep going in class. So the time that you're gonna do on the exam is gonna be, quicker, because you can just pick and go. All right. So make sure that you study on the contents, because the exam this year gonna be kind of similar to what I have here last year, but it's a little bit more tedious, I think, because we're gonna have more question on the two sample tests. Because last time the two sample tests gonna be on the show your work question, but this time the show your work, the two sample question, the two sample tests, some of them gonna be on the multiple choice as well. So be sure to take a look at the two sample question as well. All right, so we're gonna keep going in this, on this clip, because we have 4 questions left on the show your work part. But remember, this year we only have 3 questions on the show your work questions, so it's gonna be quicker for you to do the exam this year. All right, let's go. Question 1. A zoologist is curious about the top speed of wild and domesticated donkeys. He randomly samples 6 domesticated donkeys and find that they have every top speed of 40 mile per hour with a sample standard deviation 5 mile per hour. He then randomly sampled 5 Asiatic wild donkeys and find that they have the mean top speed of 43.2 mile per hour with a sample standard deviation 2.1. All right. Assume that the data from two populations follow normal distribution with equal population variances. So this means you actually have sigma 1 equal to sigma 2. All right. A, 8 point, construct a 95% confidence interval for the difference in means top speed of wild and domesticated donkeys. The R code need is given below. All right, so part B, based on the confidence interval you obtain in A, do you believe that there is a difference in the mean top speeds of wild and domesticated donkeys? All right, we're gonna do it. All right. For this year exam, you're gonna have the space below the question, so you can do the question within the exam, okay? But I mean, on the previous year, I give you an extra paper to do it. But no, this time, question two gonna be on the next page, so you have the space here to do question A. All right, so what we're gonna do here, we're gonna copy this. I hope it works. So we're gonna take screenshot, I think, and then copy, and then I'm gonna paste it on the new page here. All right. So we're gonna see if you can do this one. All right, let's see. First of all, you want a 95% confidence interval. So that's mean if you don't know the formula, you can go back and take a look at how we build the formula of the confidence interval. But this time, you can summarize everything first. So you have two samples. All right. Sample number one, I can say that it's going to be you want to know the difference in means of the top speed. Definitely mean top speed for wild and domesticated donkeys. So you're gonna use the wild donkeys as a group number one and domesticated donkeys as the group number two. So that means the wild donkey you have N1 equal to 5, right? Because you have 5, and then X bar 1, this is going to be 43.2, and S if you want S1, this is going to be 2.1 sample standard deviation. All right, so you have everything for group 1. Group 2, you have N2 equal to 6 because you have 6 domesticated donkey, okay? And then you're gonna have X2 equal to 40.0, and then S2 gonna be 5.0. All right, so you have all the numbers over there. So you're ready to plug in. So the 95% confidence interval for the mu1 minus mu2. What is the formula? So you actually know that the sigma equal to each other. What does it mean by the sigma equal to each other? It's mean that when you work with small sample size, and of course, once you work with small sample size and the population are normal as well, small sample size and sigma equal to each other, this case, it's gonna go to the pool t-test, right? It's gonna go to the pool t-test. So the pool t-test, which you actually need to use the formula as the x bar 1 minus x bar 2, and then plus minus t alpha over 2, and then square root sp square 1 over n1 plus 1 over n2. This is the formula for a 95% confidence interval for mu1 minus mu2. You can take a look at the formula sheet and then get the formula from there. I mean, they didn't give you the exact formula, but they give you the starting point here. You can see that if you start from this one, you can build a confidence interval for sure. Degree of freedom gonna be n1 plus n2 minus 2. And the formula SP is here. All right. So what we're gonna do next is we're gonna do this question, continue. That one, first of all, we're gonna have x bar 1. This is 43.2. X bar 2 is 40.0. And then plus minus, okay, let's find T of R over 2. So because you want 95% confidence interval, so you need 95% in the middle, and then you have 5% on the tail, so you need 2.5% each tail. So that's mean this one, you're going to use QT 0.975. However, the degree of freedom gonna be n1 plus n2 minus 2, right? This is the degree of freedom. And that n1 plus n2 minus 2 is 11 minus 2, which is 9. So the number that you need here, it's going to be, which one? 9 here. There you go. So QT 0.9759, which is 2.262. So it's gonna be 2.262. And then square root, oh, you need SP. So you're gonna compute SP. SP square, it's gonna be, all right, the formula is gonna be n1 minus 1, n1 plus n2 minus 2 s1 square plus n2 minus 1 over n1 plus n2 minus 2 s2 square. So you take a look at the formula sheet and you keep going. So it's actually, you're gonna have something over 9 on, right? Because n1 plus n2 minus 2 is 9. And then n1 minus 1 is 4. This is 5. So you're going to have 4 over 9 times s1 square, which is 2.1 square. And then 5.9. This is 5.0 square. And then once you calculate everything here, you're going to get SP. So let me put in the calculator pretty quick. 4 over 9 times 2.1 square plus 5 over 9 times 5 square. And that number is 15.84 9. For example, I round it to 2 digits. And then I have 15.849. And then I have 1 over 5 plus 1 over 1 6 here. And we have all the information here. Then now you can get the formula, you're gonna get the answer now. So the answer gonna be, okay, let me put it in the calculator pretty quick. And then times 2.262 and then multiply square root 15.849 and then times 1 over 5 plus 1 over 6. All right, the answer that I get here, sorry, it's going to be minus 2.253 to 8.653. So this is the confidence, the 95% confident interval for mu1 minus mu2 in this case. That's part A. So for part B, based on the confidence interval you obtain from part A, do you believe that there is a difference? So of course that, because for part B, yeah, this is part A. For part B, the answer must be we do not believe, right? We do not believe that there is a difference. Why? Different in mean top speed. Why? Because the confidence interval includes 0, right? Because the confidence interval includes 0, that means 0 is a possible value. That means we still do not believe that there is a difference. I mean, if the interval, like they are away from number 0, that means we are sure that number 0 is not a possible value. So that means there is a difference. So that is a key point, that I mean, if the confidence interval that you get it includes 0, that means you shouldn't believe that there is a difference. And if you do the hypothesis test by using the same data set, it's gonna show you that you're gonna fail to reject the null hypothesis, right? But if the confidence interval here, it's like away from number 0, let's say that you get all positive number here on the lower bound and upper bound, that means you're gonna conclude that there is a difference. And if you use the same data set to do the hypothesis test, you're going to reject the null hypothesis. Okay. All right. That's question one. All right. Question two. A recent study focused on the number of times men and women who live alone by take out dinner in a month. All right. The information is summarized below. So you have it here. Because the sample size are big enough, we would use the C statistic to perform a statistical inference. Okay, they told you that you're going to use the normal for sure for this case. Is there a difference in the mean number of times men and women who live alone order take out dinner in a month? Perform a six-step hypothesis test at alpha equal to 0.1. Part 2, perform a six-step hypothesis test at the same alpha, but this time, the mean number of time of the men group is higher than the mean number of the women group by 0.5 units. So the difference for part A and part B is like for part B, they actually want the value that you want to test, it's gonna be 0.5, not just zero in equation one. So we're gonna let men to be group number one. We're gonna let women to be group number two. And what you're gonna do for part A here, you're gonna do H0 gonna be mu1 minus mu2 equal to 0 versus H1 gonna be mu1 minus mu2 greater than equal there is that difference. So question one, you're gonna do not equal to 0, right? Because the question in part one, they want to know is there different in the mean number. So not equal to versus equal to, right? It's gonna be something like this because the question of interest is there difference. And then now, what you're gonna do next is you wanna perform the six-step hypothesis test. All right, so that's step number one. All right, step number two, what you're gonna do, you're gonna set up alpha. All right, step number three, you're gonna have the formula that you wanna use the C-test. This is actually x bar 1 minus x bar 2, and then minus 0 over square root. You have standard deviation S1 square over N1 plus S2 square over N2, right? This is the formula for the two sample t-test. Two sample C test. So this one minus 0 because the value that you want to test is 0. All right. So what you're gonna have here, x1 bar minus x2 bar, it's gonna be the sample mean for men, the sample mean for women, and then you have square root S1, it's 5.91 square over 35, and then 4.88 square over 39. All right, all the numbers here you obtain from the table over there. So I'm gonna do it pretty quick. So 24.26 minus 22.45, and then over square root 5.91 square over 35, and then plus 4.88 square over 39. So the number that I have here is 1.427. All right, this is the C-test that I get for this question. And then step 4, we need to find the p-value. So the p-value in this case, it's gonna be what? Sure. So 1.427. It's gonna be the area on the tail gonna be on the right over there. So, but this case, you have not equal to sign. So that's mean the p-value gonna be 2 times the probability that normal is bigger than 1.427, right? Because you actually want to compute the area one tail first, and then you multiply 2, because the alternative hypothesis gonna give you that you need to multiply 2, and then you're gonna have 2 times 1 minus p norm, 1.427. And then this time, you're gonna have 2 times 1 minus 0.9232. All right, let's do it. So 2 times 1 minus 0.9232, and that is 0.1536. So step 5, So you say that you actually fail to reject the null hypothesis at alpha equal to 0.1, right? Because you actually have p-value equal to 0.15, which is bigger than 0.1. And step 6, that means there is not enough evidence to conclude that the mean number the mean number of times differ. Well, I mean, you can write it down in the full text if you want to. The mean number of time men and women who live alone order take out dinner in a month differs. Something like that. Well, you can just you can carry out you know, the sentence that I highlight in yellow and then you put it there. So, but I mean, actually, we just want to conclude that not enough evidence to conclude that H1 is true. All right, so this is the 6-step hypothesis test. Make sense? So we're gonna repeat again one more time for part B. All right. Well, don't worry. I mean, the exam this year is not this long, I think. I'm trying to make it short, but I mean, when I explain in the video clip, it's gonna be super long because I need to explain it to you as well. So, part B here, what you're gonna do, you're gonna repeat the same thing, but this time you're gonna use not 0, but you're gonna use 0.5. And not equal to, you're gonna change it to greater than, because you want to know that the mean number of time men group is higher than the mean number of time the women group by 0.5 units. So you specify that you're gonna use higher than, and number you're gonna use is 0.5. So let me I mean, I ran out of space, but I'm gonna how do I say? I'm gonna copy and then duplicate. Can I copy? And can I add one more, the one that I copy? Oh, whatever, but we're gonna do part B here. Okay, let me copy this one. Oof. All right, we're gonna do this for part B. All right, we're gonna do this for part B. All right, for part B, the thing that you're gonna change from part A is that first of all, you're gonna change the alternative hypothesis. So the first one gonna be equal to 0.5 and greater than 0.5, right? Because from the question, you can see that they want to check that the mean number of time for the men group is higher than the number of time for the women group by 0.5. So this is why I do this and I do this. All right, I use the same alpha, and then my c-test, the thing that gonna change, I'm gonna change this thing to minus 0.5. You can see that I am gonna do the same thing, but this time, my numerator, I'm gonna just have one more, one more term here because I want a minus 0.5. All right. And once I hit the calculator, so I'm gonna delete this number. Once you plug in everything, just as the same as before, but you just add minus 0.5 here, you're gonna have 1.033. That is going to be your c-test. So your c-test for the question B, gonna change to 1.033. And you need the area on the tail, but this time you do not need to multiply 2, right? You do not need to multiply 2 because you only do one-sided test, right? So what you're gonna do is you're gonna do c greater than 1.033. That is 1 minus prenorm 1.033. and that is 1 minus 0.8491. 1 minus 1 minus 0.8491, and that is 0.1509. So you also fail to reject the null hypothesis as well. Okay, so when you fail to reject the null hypothesis, so you're gonna say there is not enough evidence to conclude that the mean number of times of the men group is higher than the mean number of times of the women group by 0.5 units. All right. So I'm gonna just copy this one and put it here. Just copy the statement. Does it make sense? All right. That's question 2 here. So you can, question 2 is, they test you about the hypothesis test. All right, we have 2 questions left, which is one question on regression and another one on the independent test. Let's go. I think we're gonna finish pretty soon. All right, regression part and the last one, which is the test of independence. All right. So question 3 here, the regression one. 7 samples of cheddar cheese were analyzed for their content of acetic acid, hydrogen sulfide, and lactic acid. You get a sample as of size 7, and each sample was tested and scored by a panel of judges. And the average score are as follows. So you can see that you have 7 type of cheese, 7 samples, and you have the test score from the judges. This is the test score. And you want to know that the test score, well, it depends on the acetic acid content, hydrogen sulfide content, or lactic acid content or not. So you have each cheese, you're gonna have the numbers here to show the amount of the lactic acid, hydrogen sulfide, and lactic acid here. So you use regression, here. So this is a regression. You can see that they input the score, they input the acetic acid H2S and lactic acid, and you put the summary LM score versus acetic. So basically what they use here, they use score as a Y, acetic as an X. So this is Y, X. So they're gonna build a regression based on test score and acetic acid. Though they're gonna use test score as a Y and acetic acid as an X. And then what you get is this output. So question A, what is the value of the R square in the simple linear regression interpreted? So what is the R square here? So you can see that the R square that you get is here. So that is the R square for the simple linear regression that you have between score and acetic here. So that means you're going to answer that R square is 0.7119. And how to interpret it, it's going to be in 71.19% of the total variation in test score can be explained by the linear relationship with acetic acid. Does it make sense? So when you get R squared equal to some number, the way that you're gonna interpret it is like uh R squared times 100% of the total variation in Y can be explained by the linear relationship with X. So in this context, it's 71.19% of the total variation in test score can be explained by the linear relationship with acetic acid. Okay? All right, next one. Question 2. Write out the regression line for the simple linear regression. Of course, you're gonna have intercept and slope here. So actually what you get here is the expectation of Y given X equal to minus 116.382 plus 27.086X. So that's mean I mean, if you let the score to be Y and you let acetic acid to be X, so that means your expectation of Y given X gonna be uh minus 116.382 plus 27.086x because this is your intercept and your slope from the program. All right, next one, predict the test score if the acetic acid is equal to 5 units. So that means you're gonna find the expectation of Y when X equal to 5. That means you're gonna plug in that X value to be 5, and then you're gonna get the number. All right, I'm gonna hit the calculator really quick. Minus 116.382, and then plus 27.086 multiplied 5. And you get the number that you get is 19.084. So with the content of acetic acid equal to 5 units, we would expect that the test score is 19.08048. Does it make sense? All right, next one. Interpret the regression coefficient in the equation you have in part B. So here, so I'm gonna do part D up here to have more space here. So the slope is 27.086 and the intercept is minus 116.382. Remember how to interpret the coefficients. So start with B. I mean, if X increases by 1 unit, we would expect that Y gonna increase by B unit on average. So in this context, it's gonna be if the acetic acid content increases by 1 unit, because it means if X increase by 1 unit, then we expect that Y increase by Y unit on average. We expect that the test score will increase uh, by 27.08 units on average. Something like that. This is how you interpret B. So again, one more time, when X increased by 1 unit, you expect that Y increased by B unit. So I mean, if the slope is negative, so you're gonna say that you expect that Y gonna decrease by that unit. Okay? All right, next one. Well, I mean, A is nonsense to interpret here, but you can actually interpret it because you know that A is going to be the number that when you plug in X equal to 0, as we learned in class, that if X equal to 0, then that is the value of A. So this one is the expected test score when the acetic acid content is equal to 0, which means it's nonsense because the test score cannot be negative, right? But I mean, this is how regression work because the trend data that you have acetic acid around 4, 5, something like that. So you have uh no train data set or no train X value that close to 0. So when the regression make the prediction of the regression, it's gonna be more useful, or it's gonna be useful only when you predict at the X value that near the value that you train here. So I mean, X equal to 5 makes sense because it's close to the number that you used to in the training model. But I mean, if X equal to 0, it doesn't make sense. But I mean, you can interpret it, but it doesn't make sense because it's far from the our training X values. Okay. So next one, part E, the last question on regression. If we use acetic acid, hydrogen sulfide, and lactic acid as a predictor simultaneously, so you have this, which is a multiple regression now. The multiple regression line is here. Interpret the coefficient minus 1.021 here. Remember when we learned in class, for the multiple regression, you can interpret in the same way of simple linear regression. But if you want to interpret this thing, you have to fix the outer variable to be constant. So what you're gonna do is you're gonna say that if the hydrogen sulfide content increases by 1 unit, because when X increase by 1 unit, we expect that Y test score gonna decrease by this unit. So we expect that the test score will, you see the negative number here, will decrease by 1.201 units, assuming at on average. Okay, unit on average. And do not full stop yet, because you not add full stop yet, because you have to say assuming that acetic acid and lactic variables hold constant or do not change, something like that. Well, the keyword is that you have to say at the end that the other variables do not change. In this case, assuming that the acetic acid and lactic variable hold constant, so it doesn't change. I mean, acetic doesn't change, and also lactic doesn't change as well, right? Because the only thing that change is hydrogen sulfide. If hydrogen sulfide change by 1 unit, this is the expected change of Y. Okay. All right. So that is how the regression works. So be sure to study the regression as well, because this year is going to be on the exam as well. All right. So the last question, we came to the last question. Well, here before we end the clip. So this is the test of independent question. How do Americans in the sandwich generation balance the demand of carrying older and younger relatives? The following table contains the result of the telephone poll of American age 45 to 55 years old conducted by New York Times. Each of four subpopulations, 200 individuals were polled and asked whether were providing financial support for their parents. All right, so we have four subpopulations: white Americans, African Americans, Hispanic American, and Asian Americans. We have four subpopulations. Each category you have 200 people, right? 200 individuals. So in total you have 800. Uh, and then they ask that um, whether they were providing financial support for their parents. So they have two group of support. The answer on the support question, yes or no. So you have two categorical variable now, subpopulation and support. Okay. So suppose we want to determine if two variables, support and subpopulation, are dependent variable, perform a 6-step hypothesis test at alpha equal to 0.05. Okay. All right, let's go. Part A. What write out the null and alternative hypothesis. So of course the null hypothesis gonna be support and subpopulation are independent cup. Yeah, it's like independent, it's gonna be on the null hypothesis. On the alternative hypothesis, gonna be support and subpopulation are not independent. Or you can say are dependent, the same thing. So subpopulation and uh, support are dependent as well. Yeah, that's part A. Next, part B, computer test statistic. All right, this one is a little bit tedious, right? Because you actually need to use the chi-square test, which is O minus E square over E, and then you sum of them, which this time you're gonna have lots of number here. All right. So it is suggested that you're gonna do sum row. First is 40 plus 56 plus 68 plus 84. So it's 248 on the top, and this is 200, this is 200, this is 200, this is 200, 800 in total. And you can do 800 subtract 248. So that's mean 552 gonna be there. And then this is your the sum row and the column the row sum and column sum. You already did it. So you will have O11, O12 up to O24. You have all information, but you actually need the expected E. So when you find the expected E, you can do 248 times 200 and then over 800, right? If you multiply this number to this number and then divide it by this number, you're gonna get the E11, which is the expected value, which you can see that it is 200 over 800 times 248. It's similar to you have 248 divided by 4 here. The same thing with this, you can have this one, multiply this one over this one, it's divided by 4. So basically, in every cell here, the expected gonna be 62, 62, 62, and 62. Because 248, you actually multiply 200 and 800 on the every same on the same proportion. So you're gonna get the same number. Same thing with 552 here. You're gonna multiply 200 over 800. So basically, you're gonna have 552 over 4, which you're gonna have 138 on each value on of Eij in the second row. All right, and the chi-square test, when you compute, it's gonna be starting from 40 minus 62. So 40 minus 62 square plus 56 minus 62 square plus 68 minus 62 square plus 84 minus 62 square. All of this thing gonna be the first four term and all divided by 62, which you actually can write all the common denominator if you want to, and then add the second one. It's 160 minus 138 square, and then plus 144 minus 138 square, and then plus 132 minus 138 square, and then plus 116 minus 138 square, and then divided by 138, 138, 138, 138. And then you gonna, if you hit the calculator, this is the chi-square test. All right, we're gonna do it pretty quick here. All right, let's see if I can do it. All right, I'm hitting the calculator now. 84 minus 62 square. All right. On the first four term, I have, well, I'm gonna group this four term together first. The first four term I have 1040 over 62, and then plus, and then the next four terms. So I'm gonna have 160 minus 138, then square, and then plus that 144 minus 138, and then that, and then 116 minus 138. All right. Square, and then, oh, I have the same number on the top. It's that one, 1040 over 138. All right, so I'm gonna do this. 1040 over 62 plus 1040 over 138. All right, so the number that I get here is 24.31. It's a little bit tedious, but at the end you get 24.31. All right, the last two question. Question C, what is write the command you would use to find the p-value. So if you have the chi-square test here, should 24.31. So the p-value for the chi-square test gonna be on the right hand side always, as we agree in class. And this one, to find that area here, gonna be equal to the p-value. So you're gonna use 1 minus p chi-square, 24.31, right? Because that is the value of the chi-square test. And then the degree of freedom gonna be the number of rows. You have 2 rows and you have 4 columns. So the degree of freedom that you're gonna use gonna be 2 minus 1 times 4 minus 1, because the formula is r minus 1 times c minus 1, right? So that's mean here you're gonna have degree of freedom 3. All right, so you're gonna have 1 minus p chi-square 24.31 comma 3. And then the last question, after using I, turn out that the p-value is 0.0000022, which is super small. Make the conclusion and interpret the conclusion in the context of the problem. So the conclusion that you're gonna make is, of course, you're gonna reject the null hypothesis, for sure, because at alpha equal to 0.05, your p-value is super small. And then the interpretation, it's going to be, once you reject, that means you believe H1. So it means there is enough evidence to conclude that support and subpopulation are dependent. All right. That is the end of the final exam solutions. All right. I hope you actually uh enjoy learning statistics. But this is all the final exam review. And hopefully you gonna be ready by next Tuesday. Okay, everyone. All right, I'm gonna end the clip here because it's getting too long. It's maybe 2 hours and 30 minutes already. All right. Thank you everyone for watching. And feel free to leave the comment if you see something weird or you have some questions. All right. Thank you everyone again for watching.